So let's discuss the pH scale. So here's the vertical line, but I would rather use horizontal line because horizontal line has a better understanding when we use a horizontal. So here is your pH scale. Here's your 7. 7 is the neutral. So what is pH? That's the amount of protons in the solution, right? So the pH scale indicates the relative concentration of hydrogens, protons, and hydroxides. I'm sorry. And hydroxides in the solution. So the 14 is most basic, right? We're gonna put basic here. And 0 is more acidic. So 7 is distilled water. And if we shift to the left, you see, when we shift to the left, and this is the left, and this is the terminology that we usually use, shifting to the left or shifting to the right, by saying that shifting to the left or to the right would be really hard by using the scale, so it should be horizontal. So I'm not really sure what kind of genius did this, but this particular slide is not from anatomy physiology textbook, it's from human biology. So, sorry. So, but all of these numbers and the names of these things are correct. So when we shift to the left, we are more acidic. I'm talking about the liquids in the system. If we shift to the right, we're more basic. But there's another important concept. I'm going to use red. Blood pH. Blood pH is between 735 and 745. That's the blood pH. And the neutral for the blood would be 7.4. We'll get back to this. So shifting to the right, shifting to the left. So then we have here 6, 5, pH 4, pH 3, pH 2, pH 1. The difference of acidity or alkalinity, if we go to the right, the same thing, right? 8, 9, 10, 11, and so on. So the difference between one digit, between 6 and 7, would be a tenfold, 10 times. So the saliva, milk saliva, right, is slightly acidic compared to the neutrality, compared to the distilled water. Then the difference between 5 and 6 also tenfold, and we have a coffee here. So, but the difference between 5 and 7, you have to multiply 10 by 10, and you will get 100. So the coffee is 100 times more acidic than a distilled water. And so on. So let's say apple juice. Apple juice. So between 4 and 5, tenfold. Between 3 and 4, also tenfold. But between 7 and 3, 1, 2, 3, 4. 10 multiplied by 4. 10 by 10, 100. 100 by 10, 1,000. And here would be 10,000. Apple juice is 10,000 times more acidic than a distilled water. So if we get to the stomach acid, it's 1 million times more acidic than a distilled water. Hydrochloric acid, that's your stomach, that's a salt, hydrogen and chloride. If we shift to the right, the same rule applies. So why do we need to know that? We have in red blood cells, we have something that is called bicarbonate. Bicarbonate is a natural buffer. All red blood cells transports this particular molecule that can neutralize acidity or alkalinity. So if we shift to the left, or the numbers become lower, the smaller numbers, the more acidic your environment. But the higher the number, less acidic or more alkaline because you're traveling towards the alkalinity, right? Alkaline. So if you're somewhere here, you're more basic, less acidic. If you're somewhere here, you're more acidic than basic. Here, you're more acidic compared to number 2. Number 2, you're less acidic or more basic. I'm sorry, I did not come up with that, but that's how we use this. So how can we neutralize? We can neutralize this with bicarbonate, but I'm going to simplify this. So what is acidity? Hydrogens, right? Protons. pH scale indicates the relative concentration of hydrogens and hydroxide group, hydroxyl groups, right? Hydroxide groups, OHs. So if we have lots of protons, you're more acidic, but how can we neutralize it? How can we shift this to neutrality? By adding more of OHs. It's very simple. H positive plus OH negative, and we yield H plus H, H2O, O. And then charges will cancel one another, and you have a neutral water. And that's how you can shift back to your neutrality. Because the body wants to keep the balance between hydrogens and hydroxide group. So if you're more basic, negative, right? All you have to do is just add more hydrogens. Plus hydrogen, and you also gonna end up with water. And that way you can shift back to the neutrality. All of the body systems work within neutrality, right? Proteins, some within 6.8, 7.1 or 2 or 3. So the enzymes, hormones, they're all proteins. So that's very easy for them to denature, to be damaged, right? So denaturation is just unraveling, uncoiling the protein, because proteins are complex structures. Proteins looks like this, right? So if you will break down their chemical structure, it's hard for them to perform an action, because shape relates to function. Think of proteins as a key and a lock. If you break down this conformation, now it looks like that, you cannot fit the lock. So, blood is more on the basic side, because you see 735, it's basic. 745 is more basic. So the blood is more basic than acidic. So if you're reading something like a question in the test, blah, 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 about the pH, but there is a blood, stop thinking about this, stop thinking about this, just think about 735 and 745. So for the blood, 735 versus 745. 735 is more acidic than 745, because 7.4 is the neutral. So what's the neutral pH of blood? 7.4. What is the neutral pH for any other liquids in the system? 7. But if there is a blood present in the conversation, neutral is 7.4. 735 is more acidic because we're going to the left, and 745 is more basic. So 7.36 is going to be less acidic, more basic. But 7.4, that's what our body wants to maintain. Because if we fall under here 6.8, because it's not very dangerous for all of the fluids in the system, 6.8 for blood pretty much is death. If we shift to 8.1 or even less, can also be death. Each red blood cell in the body has bicarbonate buffer. So regardless of the food you consume or the chemicals getting into your system, that buffer will try to neutralize your system. So that's a pH scale. And here is a slide. Horizontal Perfect, right? You don't have to memorize all these foods, but what is acidity, what is alkalinity? If we're shifting to the left or if we're shifting to the right, remember the blood pH. Remember by adding OHs, it's water, shifting to the right. Remember by adding hydrogens, again, you make water, you're shifting to the left. Back to the neutrality.